All right. Now, welcome to the Computer Vision Made Easy talk build. Thanks so much, everybody, for coming. This is going to be a really jam-packed talk. So I think we have 4 customers, like about 1 million products. So hopefully there'll be a lot of stuff for everybody here. We'll also be taking questions, hopefully at the end, for a couple of minutes. But also we'll take questions down at the booths. There's the Cognitive Services Vision booth and the Azure Machine Learning booth. We'll both be doing questions after there. So, we'll kind of do our best here. So lots and lots of speakers, lots of demoers. I want to thank everybody kind of who is speaking in this session. So I guess kind of what is this talk? So the kind of core idea around this talk is sort of computer vision made easy. And so we're taking a look at the products and services that Microsoft is offering to make it kind of very simple to add computer vision to your applications. And this kind of spans a lot of different technology areas, a lot of different products of the company. So everything from the cognitive services, and so we'll actually have Kelly here for Q&A later. She's a senior program manager for the Computer Vision API at Microsoft, to the custom vision service, which I'm the PM for, to the Azure Machine Learning packages for computer vision. Netta here is a principal program manager on the Azure Machine Learning packages team. And so I think we're kind of covering a wide variety of products, but all kind of in the area of making computer vision easy and then also excellent. So we'll see you guys at the Q&A at the end. And it's been, I think, for Microsoft, an interesting couple of years. So I think 3 years ago, we started off with cognitive services, which at the beginning had 2 APIs for computer vision, Face API and Computer Vision API. And these weren't even cognitive services at the time. It was Project Oxford. And now, 3 years later, there are many, many products across a wide spectrum of kind of technology areas or use cases, and then also kind of levels of depth or customization that are available in the computer vision area. And so we've done a lot of work, particularly in the last year, to focus on making computer vision very practical to add to your application. So making it very, very easy, making it very, very fast, and making it reasonable for developers to use computer vision for real business use cases. And so today you're going to see a number of demos and then a number of kind of technology areas where we've tried to optimize for just that, making computer vision really easy and really excellent for real scenarios in enterprise. And so we'll kind of be going through 3 technology areas. So starting off with kind of the cognitive services, and particularly the computer vision category of the cognitive services. Now, for those of you, I think by now most folks are probably familiar in some sense with the cognitive services. These are cloud services for machine learning. So we have kind of hosted, in the most part, hosted models or kind of hosted tools hosted in Azure that make it really, really easy to kind of do different kinds of machine intelligence type things. So everything from face recognition to speech to text to our language understanding intelligence system. These are the services that make it super, super, super easy to just drop something in your application and go. And in particular, today we're going to be talking there on the kind of the left-hand side here. So we're looking at the kind of the vision APIs. And so there's kind of six big APIs in this category. So there's Computer Vision API. So this is an API that you use for recognizing kind of general computer vision. So there's a tagger that recognizes like 2,000 objects. It has kind of adult image detection, generates natural language captions. And that's kind of all things kind of general computer vision models go there. There's Face API, so that does everything from detection to recognition to verification of faces. There's Bing Visual Search, which is new at this conference, and GA at this conference, which lets you kind of do search scenarios with images, so kind of taking photos and being able to kind of do different kinds of searches. Content Moderator, which is a kind of solution for doing moderation of lots of kinds of content, text, videos, et cetera, in kind of a human review process. Custom Vision Service, which is a cloud service for building customized object detectors and image classifiers. And Video Indexer, which is an API, so it's a web service and also a website for processing videos and kind of, again, generating intelligence from those videos. And with that, I would actually like to invite up Ben Kuss from Box, where he's the VP of product, to show a little bit how they're using the cognitive services.
Thank you, Anna. So Anna asked me to go quickly. So I have, looking at the transcription, I kind of have a personal goal where I want to finish to be able to read what I said here. So I'm going to go very fast. So if you don't know what Box is, we do what we call cloud content management. And so think files in the cloud and sharing the files, viewing them, looking at them, collaborating, workflow, and so on. We work with customers of all types, all industries, all sizes. And interestingly, you might look at this company set, and you might think of files, and you might say, this is probably all like PowerPoint docs and Word docs and so on. But actually, images are our second most common file type, and they're growing quite rapidly. Pretty soon, I think they may actually be the most common. And these are not like our end users storing their cat photos. These are like enterprise pictures that people are using for things like marketing, PR, client submissions, and just all sorts of reasons why enterprises are becoming more visual with the way that they work. But one of our challenges is we get more and more like billions of these files, and any one of these companies might have many millions. There's a big challenge, which is how do you find images? If you have a Word doc, you have a chance of finding it by searching for terms that you know. But the more images you have, you typically group them all in like one big folder, and there's a question of like, how can you ever find them? And if you can't find something, it becomes kind of worthless. So our customers would come to us historically, and they'd say like, well, how can you help? And we had kind of a crappy answer. We'd be like, well, make a bunch of folders, organize them, or go in and metadata, manually tag them. And some of our customers actually did this. They'd have like teams of people whose job would be to like tag photos, which is seemingly like a bad idea. We felt bad about it. But when we learned that Microsoft had their computer vision APIs, we thought this was very cool, and we actually built a full product around it. So we have something we call Box Skills. And Box Skills you can think of as a framework that lets us take these awesome machine learning technologies like computer vision and incorporate them directly into Box automatically. So for our customers, they just go in and they're like, I want to use this computer vision image intelligence API. And then we just start to use it to structure our content, such as images. We don't only do images, we do document structuring, we do audio and video, but for today's topic, we'll be talking mostly about images. And so to show you this, I'm going to just switch to a demo here, and let me pull up my demo. So some people, I'm sure some of you are familiar with Box. I see a guy has a Box shirt over here. And so here is Box in general. You can think of it just like other tools. And so I have a bunch of different folders here. So let me take a look at a couple images. So here I've got this, and this might be, here's an example of an image that we might have from it's like a typical screenshot, so we might use it for their website or for a catalog or so on. But then you notice on the side here, we have automatically tagged it using Computer Vision API. So this is now inside part of Box. You can see it labeled. This is outdoors, this is a park, this is a forest. And it even generated a caption, which we really like this feature. A wooden bench sitting next to a tree in a forest. I think that's pretty good. And then here's an example. This is one of our customer buildings. So if they were trying to find this amongst many images, they might search for a building or city or skyscraper in the description here. They could even, like, any of these words would all become searchable. A large body of water with a city in the background. And so you get this sense of, like, by applying this image recognition technology to all the files in Box, they become more structured, categorizable, filterable, searchable in ways that our customers have been asking for a long time. So that's been very helpful for us. And this is something that we are actually releasing now. It's currently in beta, and we're getting very good feedback from it. And then in addition to the computer vision, the sort of the off-the-shelf, we also have this concept of what we call custom skills, which is the idea of taking any of these APIs that you're showing and then applying them, making a custom, what we call a custom skill, I'll show you in a second, and then applying it to your enterprise. So in this example, we actually took the Faces API and we trained it for our CEO and then my boss, our Chief Product Officer. So you see on the side, it's labeling the people here. So G2 and Aaron. And so it's been pretty good. Any picture, it just goes as G2. And it could be different types of photos. So here's a picture of Aaron, and it found him. And again, I can search. So if so this actually came in from our customers. Like they're constant. We've been working with a couple foundations, and they have a bunch of pictures of some of their key people, and they're like, I need to find all the images of this like key people so I can make them quickly available when people ask. So this kind of technology here would help them. And interestingly, like as we were going through setting this up, this came up and it said Aaron Levy here, and we were like, oh, this is the Face API kind of like it's not perfect. I guess he kind of looks like Aaron, but if you look in the background, actually he's here. And so this is kind of fun. It's almost like a Where's Waldo kind of effect. So that's the demo, and let me switch back here to my So how does this work? So we're developers here. So the idea for us is that when a user uploads a file to Box or copies it or generally creates a file, then what we do is we then send it to a Azure function. And this is what we call the skill, in this case, the image intelligence skill. So it's kind of a webhook sends off to the skill. And there's a little bit of code in this Azure function that basically takes the file, the webhook from Box, goes and gets the image, so it like downloads the file to the skill, and then it hands it over to the computer vision API, which gives us back the nice JSON with all this interesting info. And then we turn around and we write that to our metadata. And then the labels and everything you just saw in that demo is immediately available. The whole thing takes a second or a couple seconds. And so from the end user's point of view, they upload a file in a box, and then bam, they get all these labels. It's immediately searchable, and it has all these great benefits that we just mentioned. We're looking forward to releasing this soon and to using all the new cognitive services that come out. And with that, back to Anna.
Oh, it was totally awesome. Thank you. Yeah, so I think, with sort of the cognitive services, this is really sort of the goal that we have, is that you really can just sort of plug in applications and not worry about these common repeatable tasks. So, if your company makes widgets, your company makes websites, whatever your company makes, things like kind of general image classification for generic categories, things like recognizing faces, just shouldn't have to be things that you have to worry about. You can treat them as solved problems. You can just call them into the cloud. And so all these services have been designed to kind of take common repeatable tasks and make them really, really easy to do without having to kind of expend extra effort, so you can kind of focus on sort of what your business focuses on. And so with that, I want to talk a little bit about the news that there is kind of for these APIs, sort of what kind of up a build. And so the computer vision API, so if you recall, this is the API that does kind of general tagging, that does recognizes an image as adult, what color it is, et cetera, et cetera. This was the API that did the tags in the Box demo that you saw. Historically, it's had captioning, so you can take an image and generate a caption for that image, kind of a natural language caption based entirely on the contents of the photograph. So prior to today, that was only available in English. So in this image, for example, you would say a black and white photo of a city. Now we've added 3 additional languages. So you're now able to take the same captioning and use it in Chinese, Japanese, and Portuguese. It's been really exciting to see what people do with image captioning. You'll notice if you're using kind of the most recent version of Office and PowerPoint, for example, that we now do auto alt text generation. And that's actually using kind of these same captioning technology. For accessibility reasons. So we're very excited to have a couple of additional languages available for captioning. There's more updates to the computer vision API, and I think one of the things that many folks in the room probably will be most excited to see today. So computer vision API has OCR, so optical character recognition, basically what's the text in this image. And it has gotten a lot better. So you can see kind of in this image, kind of OCR v1. So we got what was available prior to this week. It's good. It was originally trained for document classification. So if you had, large quantities of scanned kind of like long text, you would do okay. But in the wild, sometimes struggled a little bit. Now with kind of OCR 2.0, you see kind of substantial improvements. And so you see on the right, kind of this does a lot better. But it also isn't just doing better in the wild, it's doing better in the wild in somewhat challenging conditions. So you can see here, we've got this at an angle, we have kind of some material in the front is obfuscating the text. Previously, we did not see that text. And now with OCR 2.0, all that is kind of being read incorrectly. Kind of in this example here, where you have sort of some kind of light, even handwriting type text. In some cases, old OCR is a bit of a fail there. New OCR, much, much better. This has been one actually of the top asks for customers. So we get a lot of emails from folks. And the biggest ask, actually, I think in the last year or so has been kind of make OCR better. It's better. Face API. So this is what lets you do things like face detection, face recognition. Has had a bunch of updates this year. The big update actually came out in March, but in case some of you missed it, we've upgraded face recognition to a million scale. So you can now have 1 million people whose faces that you recognize using Face API. So previously I think the limit was on the order of 10,000. If your company employs more than 10,000 people, this becomes a very relevant update to you. One nice thing that's nice about Face API kind of versus other similar APIs is that with face recognition, you're able to provide multiple example photos per person, which in many cases results in kind of much higher accuracy. So kind of different products on the market, not all of them let you do that, and it's like a very nice in Face API that you're really able to provide a number of photos to help you have kind of even better recognition. But yeah, Face API kind of getting bigger, getting better every day. Bing Visual Search. This is kind of a new and exciting update. So they have provided a video that is more eloquent than me. So this is the same experience from Bing.com, but now as an API. And so one little flag there, the Visual Search API is available in GA today, and the Visual Search developer platform is available in alpha today. Content Moderator has some huge updates this year. So Content Moderator is a tool, it's kind of you get a website, you get an API for doing content moderation, kind of a user-provided text. And this year they've added a bunch of kind of new stuff, in particular the ability to do content moderation for video. And this PII detector. So you can kind of see in this example text here, we're starting to kind of recognize things like emails, addresses, phone numbers, IP addresses, things that you may want to automatically flag for your human content moderators to check, should that really be on my website? And so, I think the one nice thing about content moderation is that all these flows here are kind of a human-in-the-loop type flow, where there's automatic classification done using technologies like Face API, using technologies like Computer Vision API, using some of the core, new things that is exposed via Content Moderator API, and then you're also kind of appropriately surfacing things to human content moderators as needed. Video Indexer. So incredibly exciting news about Video Indexer. It is now in paid preview. And Custom Vision Service. So this one has a special place in my heart because this is what I work on day to day. This is our cognitive service for generating your own classifiers and your own object detectors using your own images. So if you saw in the keynote demo that kind of Scott or not bit, Custom Vision Service. If you saw in the keynote demo in the MBA section where they had kind of recognized hoops and balls and shoes, Custom Vision Service. And in fact, the developer who stayed late to do data labeling is sitting back there in the back. So shout out to Ping for staying very late on a Friday to label some images. But there's a bunch of new stuff for Custom Vision Service here. So one big feature is object detection. So previously you could build classifiers, now you can build detectors. Two, there's been substantial back-end improvements to the machine learning pipeline for classification. So if you've previously trained a classifier and you were good but could do a little better, retrain. Next, we have introduced a bunch of export functionality. So exporting what we call kind of export to containers. We give you a Docker file, a model, and some service code. So you can now take the same great API but have it kind of hosted somewhere else. And to Onyx for Windows machine learning. And then finally, we've increased the size of the S0 tier. Now, since we're going to do actually a couple demos of Custom Vision Service, I want to kind of ground a little bit, since this one is a little more involved than, say, the Face API, where it's just, give it a face. With Custom Vision Service, you're providing your own training images to build your own custom classifier. So as you saw in the demo, like in the keynote demo, they wanted to have kind of Scott and not Scott. So the kind of general process you're going to see in these next two demos is upload images, train, evaluate. One more kind of context setting is just to get a sense on object detection. Because sometimes we talk about object detection versus image classification, and maybe the difference is maybe sort of not so obvious. So in image classification, what we would have said on this image is just Apple. So it's kind of an image level tag. And in kind of object detection, what you're doing is you're actually finding the bounding boxes, so the location of objects in images. And this has been a major ask from customers, so we're excited to have it here at Build. And with that, I am very happy to have Andreas Araban come demo. His title has vanished from the slide, but he is the CTO at Imagination Holographics, and...
Well, almost. I'm the CTO of a startup called Industrial Holographics. We deal with HoloLens application and also the America guy for DANET, a traditional Microsoft partner. One of the problems that we have is that a lot of customers and everybody asks us for, please, can we do AI? Can we do AI? And then you ask them, well, do you have an AI expert, a deep learning expert? The answer is no. And they don't have the budget, and we cannot find one. So we found in a lot of prototypes to get over the first cliff, or also to deploy products or solutions that use custom vision type of solutions, like image classification or now object detection. It is a powerful approach to get over the cliff. So how it works is, you have access, first of all, to a nice portal. In the portal, you have projects, and the projects represent what you want to work on, right? For example, in our case, it was the task that we set ourselves is, come on, to detect fire hydrants. Oh, now they're showing up. Well, why would we want to do that? Well, it sounds pretty generic, but you could think of an app that reminds you when you're parking that you're not too close to a fire hydrant. That is one of the examples. And the way you do that, basically, like you have an image, and in the image you mark the bounding box of what you care for, and you give it a label, right? So, and when you're done with all that, at one point you click train, and it will generate for you what they call an iteration, and the iteration is then what you can predict against. When you can have multiple iterations and over time get better with better example images. But now let's switch gears a bit and look at what does it actually mean for a developer, because it's not just a portal. The portal just uses APIs like everything, and there are RESTful APIs that connect to the Azure cloud service that is custom vision. And in my case, I'm using a wrapper and a C# API to work against that, and I've just based my work on the example app. So if you want to predict something, it's as simple as calling, basically establishing a connection to an endpoint. You provide an API key, and typically you don't need to provide a URI to it. There's a default URI, but in my case, I needed to do a demo environment to provide the API. Then you open an image as a stream in this case. The API supports a stream, and call, in my example, the prediction. And the prediction will give you a result. Now the result is, again, it's a nice object here, come on, that you can drill into. And it is an array, basically, of predictions, what it found in the image. And in my example, interesting enough, the first example has a low probability, so 0.4%. So probably that's nothing we care for, but towards the end, you should find, somewhere in here, there's a better result, right? To get back to the better result, what we do, we just sort the results in the other order of the probability. And we'll draw the result image, which is not very visible for some reason. So let me try that again with another example image. Sorry. Yeah, here. So I think it was just too small, so my drawing failed. Now, you see another marking here that says keep image. There are two options to work with custom vision in general. You can let people try and classify things or find things, and then those things show up as a result also in the cloud portal. If I go back to the portal now and go to predictions, you will see that what I just used in my app is now available in the portal. And the powerful thing is now somebody, like a human being, can look at it, was it a good prediction or not, and can just click at it, confirm that it is actually a hydrant, and bang, it becomes then a part of a training set for the next training run. Now I could click train, and the next training iteration will hopefully get even better results. Now, briefly, again, back to the API, the other things that we can do is we can really work on the whole automation of the whole process. So we can even create a whole project in the API. For that, we have a different API, the training API, with a training key. We call that API, and step by step, create the project. Then you should see in the portal that a new project was created. That's pretty boring. It's just empty, right? Then you add tags to that project, hydrants, and it gives you the option to specify then in your API already the bounding boxes for images that you have. Why is that important? Because you can actually find a lot of data sets online that you could convert and just automatically then upload in masses. In my case, I only manually tagged one fire hydrant, and will add that to like basically a dictionary. And in my dictionary, at one point, when I find a match, we'll just add it as a region to what I then upload to the cloud. Yeah, here is that's the call. It's a little long, but it's really fairly simple if you do it. It supports several modes. It has a batch upload mode that does all the magic for you. So you can upload like 50 images in one run, or you can go image by image. So I run that in the background. It might take a few seconds. And when I go now to my new project, at one point I should see, hopefully, yep, that some images are being uploaded. And it got tagged automatically. Well, what I want to say also that this is not just a toy. We actually had a shootout once with a guy working on TensorFlow and trained not this object detection, but image classification on 35,000 images. And the results we got with custom vision were on par of what a data scientist, deep learning expert was able to do in over a weekend. So it is something really to look into if you want to have good results. And if you're a developer or just even somebody just using the portal, I worked with doctors who worked on their own on the portal, and they did some basic classification. They didn't call me anymore. They didn't need me. They were able to prove their concept, and they're now applying for a research grant. That's a great tool. API-wise, again, everything is REST. We have a good C# API and a Python API available immediately. The .NET API is both regular .NET, I think 4.5.2, and .NET Standard 1.4 up. So that concludes on .NET Core supported through NuGet also. So that concludes my part of the demo, and I think there's Anna somewhere. Oh yeah.
That was wonderful. Thank you. Yeah, I think Andreas really kind of hit the needle, hit the hammer on the hit the needle somehow. There's an idiom for this. You've hit something, it's on the head. Got this, I think this really kind of grasped what the sort of core of what we've tried to do here, which is to make these kind of very easy to use APIs, where you're just able to kind of deal with the process of uploading images, of finding your domain, and you're not having to worry about sort of the little fiddly bits on the computer vision side. So in the background, we worry about spending a lot of time making training super, super fast. We had a research team spend 6 months making training just hyper fast. Kind of substantially beating kind of published state-of-the-arts by very large amounts. Or worrying about how to augment your data, your learning rate, kind of all those things that you kind of could worry about, we just sort of automatically handle for you in the background. And so the idea is you just have to have simple REST API where you're uploading your images, you're training, you're relabeling, and it just becomes kind of very, very simple to do. And so, there's one other big feature we talked about. You saw it a little bit of build, but this idea of model export, I'd like to kind of show you a little bit more today where that is going. So I have here kind of just a toy demo. These happen to be the sodas that are in the Microsoft cafeteria. So kind of earlier today, I went and I trained these, and I actually think that these are even the same images that we showed last year. But what's new this year is you're able to take this model and now export it. So in some cases, it's wonderful to have your models that you've trained hosted in the cloud. It makes it easy to call. It's platform agnostic. Just sort of REST API call, and there you go. But more and more, we're hearing people talk about how they want to do things on the edge. Maybe they have network connectivity issues. They're concerned about latency. They're concerned about bandwidth. And so we've listened to that. And so starting last September, we introduced export to CoreML, which is a format supported by iOS 11. Back in, I think, November, December, we came out with export to TensorFlow for Android or for Windows. And now at Build, we have export to Onyx, which is a format supported by Windows Machine Learning, which I think there's a number of sessions about at Build, including a workshop you can attend tomorrow morning on export to Onyx with Custom Vision Service from the Windows ML team. And then finally, we have export to Dockerfile. So this gives you, as kind of was mentioned earlier, this gives you the ability to download a Dockerfile, your model, and some service codes, and kind of go and use the same API. And so I will show you that very quickly, how you might be able to do that. So what I have here first, let's go and send a prediction just to the cloud service. As you can see here, I have a curl command, and let me show you the photo that I'm uploading. This test image here. So we send that up to the cloud service, get the results back, and it's sorted. Okay, so here, kind of probability with kind of fairly high confidence. We think that is Mountain Dew, which seems roughly correct. So that's kind of how you kind of normally do things. Now I can also take the same thing, but run it locally. Just in the background. So I can go Docker build a live demo. So that was supposed to be cached and therefore really, really fast. It's not cached, and Docker is running. Okay, oh, there we go. Okay, so we did use the cache there. It was a little less fast than I expected, but a lot's going on this poor machine. You can see there we have built this, and now we do. Let me just make sure I do this right. Docker run -2. No. What do we call this? Live demo. Oh, yes, great. I got them running. And then now, what you can see here is that we can take the same command that we ran earlier. Don't need the prediction key anymore. We got the same command and just swap out the URL, point it at localhost. We're going to have to make a change there because we... Yep, yeah. No, when I rehearsed, it was to 8,000, so got to move that up. And now, printed much nicer, we go out and see we get roughly the same results. Okay, barring an issue where you don't do the demo correctly, you get the same results. The nice thing here is you're able to go export your model, build a container, run the, oh, you know what it is that I had the old version of the model. You didn't see me copy and paste the thing that I downloaded into the thing. So if you do that correctly, you get the same results, or roughly the same results. It's very nice. But the actual reason this is useful is you can go take that container and kind of go put it wherever you want. So there's instructions for how do you go have this deployed using Azure Machine Learning. You can go put this up in Azure App Service. You can go take it to Azure IoT. So you can host it yourself some other way. You can run it locally. So suddenly you can take these models that you train in the cloud and kind of run them literally anywhere. And so we kind of have called this thing that we're doing train in the cloud, run anywhere, because we've kind of tried to get basically every platform that we can think of the ability to go run your models wherever you want. And one of the exciting places actually that you can go take your model is to this new camera that was announced in the keynote. And if you have an interest in learning more about this, the Azure IoT team has a session and I think a workshop that shows you how to take your model and using Azure IoT Edge, use it with the Vision AI Dev Kit. And they also, I think, will be down in the booth after this session to answer more questions. But really, I think really train this thing in the cloud and kind of go and run it anywhere. So we have gone through a couple of steps. So we talked first about the cognitive services. So these are the kind of pre-built, easy-to-use models in the cloud, face recognition, computer vision, super easy, do a REST call, get the thing back. And then we talked a little bit about the custom vision service, which is one of the cognitive services, but it's customizable. So suddenly you can go from something that's pre-built to something where you have the ability to train it yourself, customize it to your own needs, kind of build your own models. But in some cases, customers need a little bit more. So maybe they want to, you have a data science team that wants to have kind of more control over parameters or be able to do kinds of experimentation that isn't offered by the kind of customizable services. Or you want to do something like defect detection where you have to use some different techniques. For that reason, we have now the Azure Machine Learning package for computer vision. And this is a package that is designed to make it very, very easy and quick for your own data scientists to experiment with, to build, and to publish computer vision models. And it was actually built by our own data science team, which had taken some of the problems that they had found themselves solving over and over and over again. It took a bunch of, they had lots of little kind of repositories that the team had used and said, can we build a broadly useful tool that can empower data scientists, developers, to build computer vision models faster and to build better models. And so this is a pip installable extension to Azure Machine Learning. And to talk a little bit more about how this is being used, I'd actually love to have Nori Nakamura from Toshiba, who is their executive officer and vice president of client solutions, come up.
Thank you, Anna. Oh, just a minute. This one? OK. Oh, oh. No, just. Oh, okay. Oh, okay. Sorry. So, good afternoon, everyone. So, my name is Nori Nakamura. So, I'm executive officer of the Toshiba Client Solutions. So, I'm happy to introduce you our newest development, our mobile edge computing, similar intelligent edge. So to showing with you to share our concept to making to the videos. So we are much appreciate and the computing vision is running on the So our Dyneige, these devices like this one, and also to the glasses we are developing now. That we are to execute we are doing the object detections. So this one is I'm wearing now. That looks cool, I hope. Okay, at first, let me play a brief video on how we are using Dyneige. This name is Dyneige devices and machine learning to help one of our customers in Tokyo. So please roll the video.
Toshiba leading innovation.
Thank you very much. So in this video, you saw how computer vision and object detection are used to automatically and accurately identify wear and tear on equipment. It also helps any field technicians to perform appropriate maintenance regardless of their qualification levels. You also saw another application allows any field technicians to do complex operation on electrical panels. By increasing the reliability of inspections, our customer can minimize the risk of total equipment failure and save the cost of downtimes. Additionally, each inspection is restored and stored into the cloud. We can also use machine learning to analyze the data and build predictive model to optimize the maintenance cycle and patterns. In other words, our customer will be able to dispatch technicians only when and where they are needed. This is a brief overview of architecture we used. The created AML model is downloaded into our Dyneige, these devices, and perform standalone object detections using our smart glasses. This application realizes our mobile edge computing vision. This application was done using out-of-box capability of Azure Machine Learning package for the computer visions. The core team of this project only has one data scientist and one software engineer. Not only this enables us to reduce the time to solutions, but also allows us to streamline our resources. And most importantly, focus on the customer's data from the very, very beginning of this project. Okay. So one key point is machine learning made the creation of AI model much easier. We are able to gain 30% improvement in productivity as well as 70% increase in efficiency. If we had created our own modules, we estimate the project duration would have been several months and requires a much bigger team. Instead of this, our team of 2 was able to accomplish all deliverables within 2 weeks. What I show you today is one of our several projects using our mobile edge computing and cloud. So if you are interested in learning more, please visit us of the expo area on booth CE80. Mannequin doll is standing, it's so very funny, so please come in. So I'm waiting for you. Thank you very much, and have a nice conference. Thank you very much.
Thank you so much. That was awesome.
Yes, thank you, Anna.
So I think just kind of to recap, we have the Azure Machine Learning package for computer vision. And it is this pip installable extension for Azure Machine Learning. And you can kind of do things in the area of classification, detection, image similarity. And once again, these are fairly high-level APIs for this kind of workflow of building computer vision models. But I think kind of a little more, you get kind of a little more detail kind of in each of the sort of steps below. I think to talk a little bit more about kind of the experience, the workflow, and the awesome work done at Iris is Jocelyn Debian, who is a data scientist at Iris.
Thank you, Anna. My name is Jocelyn, and I should have called my presentation how to pack 3 years of work in 5 minutes. So I will be fast. Okay. The Iris is a startup based in Florida, in Pensacola, and its mission is to stop the preventable blindness. By that I mean blindness that is due to a disease called DR, diabetic retinopathy, which is a manifestation of diabetes in the back of the eye, on the retina, and the eventuality is that someone having this disease will go blind. So the problem we're tackling is to triage the patient. All our patients are diabetic patients, and we need to triage them. Triaging means that we have to separate observable patient from referable patient. So patient having none or mild DR from those who are in the late stage of DR. We process over 20,000 images per month, and probably that this number will double by the end of this year. And we probably own the biggest database of graded image of DR patient in the world. We have more than 300,000 images into our databases. It's a kind of magical playground for a data scientist. So how do we solve that? What I did is to implement a two-stage or two-phase predictor. The first one is on your left. The first one is a classical image processing predictor using techniques like radial symmetry, entropy, pattern matching, and some classifier like boosting and random trees. And there is some hard math theory like the blood vessel reconstruction with Fourier theory and harmonic descriptors. All that is packed into one image that I call an annotated image, where the region having the highest probability of having a lesion are highlighted onto the normalized image. All those images are sent to a classifier. So a convolutional CNN classifier. In our case, it's a CVNTK. The classifier is trained on 6,000 images and validated on 2,000 images. I calculate that 6,000 images is enough to use the training package, which is a ResNet 50 pre-trained model with data augmentation. So when it's trained, it's validated on the 2,000 image, and I got this results. So if you look at the last row, which is the classifier for observable versus referable, the accuracy is around 97%, which means that out of 2,000 images, about 50 images are misclassified. So there are about 25 images, false positive images we don't care about. We care more about the false negative images. So patients having signs of retinopathy that are classified as normal or as observable. But if you look at the second row, the classifier is very, very good as separating normal patients from patient having sight-threatening DR, meaning patient being at the late stage of DR, severe and proliferative. So that means that out of the 25 false negative images, about only 2 or 3 are real false negative. The other ones are being observable images. So it makes a classifier which must misclassify about 2 or 3 images out of 2,000 images, which is very, very good. Our system is running on Azure, totally all on Azure. An image is shot by an operator, sent to our web API, stored into a blob storage. Then a message is sent over a service bus, and a Azure image pick up the message, fetch the images, and send the image to the classifier, and the result is sent back to our database. So, what are the advantages of using AML package? Well, it's really easy to use. All is done into a Python script that can run at the command line or inside ML Learning Workbench. The update of a model is done through exactly the same workflow. We have a quick response times. It takes less than a second to score a high resolution image, and we got from the CNTK, we got very high accuracy. 97% is. Of a DRS image, actually, of a patient having DR, if we look at the enhanced image, we see that there are hemorrhages, so blood leakage inside the retina. And if we classify it with the model, it returns a referable image. It's all done in C++. The image is normalized, is base64 encoded, sent to the ML server on Azure, decoded, and returned back to this application. The next image, so you see it's less than 2 seconds. On a VM, on a small Mac, and with a slow Wi-Fi connection. This one is an image of a normal patient. No lesions. And if we ask the model to classify it, it returns as an observable.
Awesome. Thank you. This is completely fascinating.
Thank you.
This is just wonderful. Thank you. There's been a lot in this session. And so I think one of the kind of big takeaways I want to sort of make sure that everyone walks away with, put them in the wrong order, is there's really kind of different levels of tools. So for a data scientist like Jocelyn, there are packages that are here and available to you as a Jupyter notebook. And so when you run through the computer vision package, you're running through kind of the entire step of building a machine learning model with a very high level of control over every single step, from data creation, image visualization, annotation, all the way down here. And it's all the way down here through kind of interpreting and understanding the results. On the custom vision service, you're looking at sort of how do you do image classification, object detection in a way that's more developer focused. So we try to build the best classifier for you automatically. And then there's the cognitive services, which are these sort of, for the most part, pre-built or in some cases customizable services to make it easy to do these very common tasks for computer vision and for machine learning. So face detection, face recognition, OCR, computer vision, stuff that you should think of as basically a solved problem for you that you can just pop into your application. And so while there's been a lot in this session, everything from Bennett Box to Andreas, at Industrial Holographics, to Jocelyn and Nori, kind of all showing a bunch of different tools and how they use them for kind of very, very different applications. I think if you kind of walk away with kind of one message out of all of this stuff, the thing to remember is for sort of like every level of abstraction that you want, we've tried to make tools that make it extremely simple to use computer vision so that you can focus on building a very accurate model very quickly. With that, I think we have reserved 15 minutes for questions. And so I'd like to have, we'd be happy to have those now. I will leave up on the board just some information about how to do evaluations. Obviously, I always appreciate your feedback. Yes, so there are microphones for questions on either side, and I see somebody is ready here. And I think Netta and Kelly will also come up for questions. On your fire hydrant display, on your that particular one, the bounding rectangle, it was always a bounding rectangle. Could you do that with like a bin of parts where some of the things you're trying to identify are covered up by other things, so you get little pieces and they're not really square, it's kind of a circular pattern? So let me kind of answer that sort of in two parts. One is a question that I first thought you were asking, which is, can we do polygons? And the answer is no. And so the second question, so if you want to do things where like parts of the image are obfuscated and so on, kind of regular old bounding boxes with detection, usually they can work reasonably well if you provide a lot of sample data. It really kind of depends on the scenario. So it's hard for me to say kind of in abstract without seeing any data like, oh, I think that might work, or like, oh, that might not work. But the really nice thing is if you want to try it, you really can try it in like half an hour, and if it doesn't work, then you know.
I was just wondering what image formats you support for training.
So all the cognitive service image APIs take the same, and I want to say it's JPEGs, PNGs, TIFF, and then GIFs, but only the first frame. But somebody scrunched their face, so if I'm wrong about that. Did I miss one, Jen? Oh, okay, we don't support SIF either. So, here we go.
That's what we needed.
You ready?
Oh, yes, yes, yes.
Okay. The example of exporting a model to an IoT edge device,
Yes.
can you do OCR on an edge device?
This is an excellent question. And one that I will have to casually demur on. So, I think we have heard your interest in taking, more capabilities beyond custom vision on devices and onto the edge. And I think there's nothing particular we have to say at this time, other than you should go bother Kelly.
Can I go ahead?
Yeah, please.
The OCR, which you mentioned, OCR 2.0, does it also include, does it just include the text or like the format of the text? Like is it bold, is it italic, or?
It will only show you what the text is and the angle at which it was. So the bounding box of the text, the angle of it, and then what the text is. It doesn't give you italics or bold, but we'll take that as feedback. And
the position of the text, is it available right now? Or?
yes, so it will tell you where the text is. If it's at an angle, it'll tell you that, and then it will tell you what the text says.
Okay, thank you.
Hi, for custom vision, can you define the limits for detection? Which data you want to actually display, or you're interested in, the probability that it is actually what it is?
So I think if I'm understanding the question, you're asking kind of what kinds of outputs you'd like to see from custom vision?
No, can you define the limits, thresholds of the probability score?
Yes. Oh, you absolutely can do that. The question was, can you kind of specify probability thresholds? So what we actually do in the custom vision service is that we return a probability and then kind of leave it up to you to decide at what probability threshold do you interpret this as correct. And so when you see in the custom vision service, I think you saw kind of some precision, some recall numbers, some kind of summary statistics about the performance of the model. Those are reported at a particular probability threshold, but there's a little slider in the top left. And so if you move that slider to the left and right, I think 6. So you actually, Kelly's showing you right here, as you move this probability threshold slider to the left and right, this sort of gives you the summary statistics at that probability threshold. So actually, yes, you're strongly encouraged to select your own probability threshold for your own application. In certain applications, you might care more about precision or recall, just depending on whether or not you care about false positive, false negatives. I think in Jocelyn's example, like you really don't want to miss people who have DR, whereas in other cases, maybe you only want like really high precision. So yes.
I just wonder if there's any use cases on the mixed reality platform and on the HoloLens.
Oh, so question about HoloLens. Wow, so I actually don't work on HoloLens and don't generally have a lot that I can comment about that. I will say that I have seen on YouTube a ridiculously bananas cool demo that somebody did with Custom Vision Service where they were like using Custom Vision Service to identify these like gestures. It was extremely cool, but our team I think has not done any particular HoloLens integrations. I think actually Andreas you should chat with after the session because he has done a lot of really cool stuff. That's I don't think on YouTube yet.
But with the Redstone 4 build and HoloLens, you can run Onyx models on HoloLens.
There we go. With Redstone 4, you can run Onyx. So
Redstone 4 is out.
Thank you.
I was curious on what exactly you do with the image that I send for recognition. Do you retain it? And even if you don't retain it, do you use any part of what I'm submitting to improve your service?
It's a great question. I'm going to give a short answer that links to a long answer, which is on the Azure Trust or on the Microsoft Trust Center, there's a pretty extensive discussion of how the cognitive services kind of work. I can tell you in the case of Custom Vision Service, for example, we act as a data processor. And so we're not using your data to go improve other services at Microsoft. There's some details there on Bing and the Bing services and how they work. I am not a lawyer. And so I will refer you to the Trust Center, which I think is intended to be very, very detailed and precise about what that stuff is. But generally, I think like for the services you saw, for the most part, yes, we're kind of respecting your data as a part of being in the trusted cloud.
And just to add on to that, for all of the vision cognitive services, we are a data processor.
Yes, because technically the Bing one is in the Bing section.
So you sort of kind of started to answer the question, but with the OCR 2.0 or whatever you're calling it, do we have any way of knowing like inferred importance? So like the closed sign, it said closed, but it had like a weird quote. What's important is the word fact says closed kind of thing for a lot of cases.
So we're really giving you, oh, sorry, Kelly.
So we don't have any way of saying that this is more important, but we do give you the size of the box. So for that case, you could say any text that is in the center or any text that is larger, but that added inference of what is important and how you determine that will have to be from on your side and based on position and size.
Yeah, I mean, these are really designed to be building blocks. So, I think we provide kind of very general capabilities in these cases that you can then kind of build your own custom logic on top of.
So I have a quick question. For the cognitive version service, do you have to do it on the cloud or do you have on device? Basically, our situation is that sometimes you don't have internet connection. Or even you do, then our customers, sometimes they don't like to send the data out of their control, into the cloud or something.
So for now, the cognitive services vision category, with the exception of the custom vision, train in the cloud, run on the device, are currently all cloud services. I think we've heard this feedback a lot, but there's nothing kind of more that I have there right now.
It's not planned yet right now. So, or anything.
It's not something we've talked about that we're doing or not doing. So that's all I got for you.
Cool. All right. Thank you.
Is this service going to remain free?
So I think none of the services we showed today are completely free. There's a free tier. So thank you. Andreas answers these questions better than I do. So with all the cognitive services, including custom vision service, there's a free tier. And then you have the ability to kind of pay for an additional quantity. And then on the Azure Machine Learning package,
the package itself is free. It's an extension to AML, Azure Machine Learning.
I'm sorry, I didn't hear that.
The package itself is free. It's an extension. It's Python installable extension. You need an Azure Machine Learning subscription for it.
Right. In the Toshiba example, you had multiple bounding boxes around the chain links. Can you identify different objects, not like the same chain link? Can you say one's a chain link and have another bounding box around a hydrant? Or
yes, we can identify the different objects or different bounding boxes in the images.
Okay, so there's multiple objects, each one would.
Yes.
Thank you.
Hi. If you build a model, can I publish this model to Cortana library?
I have no idea. I am so sorry. If you send me an email, get me an email after the thing, I will find out for you.
Okay. As a feature, is that I can sell my model to others in the marketplace?
So we don't have a marketplace right now. I think
Cortana library is there, so you can go and download any of the model from there.
Got it. I am so sorry. I'm not super familiar with that. I will look into it. It's a huge company, so yes, awesome stuff everywhere.
For the custom stuff, I recall that it said 50,000 images max. I have a client that's looking at wanting to train off of 1 million images.
Let's talk later. I have a lot of questions for you, so
perfect.
Let's talk later. I'll be at the booth. I'll be around here.
Okay, so for the custom vision service, is there any way to tune the parameters? For example, if we are using the deep neural network, there are lots of parameters to tune. And from these custom vision services, it seems there is not.
Yeah, you were exactly right here. You've hit the nail on the head, which is the idiom that I missed earlier. So you're 100% right. It's custom vision service. There's not a lot of kind of parameters where the only option that you can do is choose your domain, which is basically kind of choosing the base model or featureizer.
Or landmark or something like this one.
Exactly. If you want to kind of do kind of more options, more parameters, I think this is where we would kind of send you to the Azure Machine Learning package for computer vision. We've kind of split this out in having kind of a library that's kind of well-suited, or packages that are well-suited for when you want to have lots of ability to change parameters, and then kind of a cloud service that's more, let me give you my images and we'll do what we think is best.
Okay, thank you.
So.
these days we're actually evaluating Google Vision API and Microsoft Vision API. So from your personal point of view, what can be the guidelines for the customer to choose?
I would say that
maybe it's
both companies do a great job. We each have things that we excel at. The best way to test is to try them. They're both openly available. I can't really comment on Google, but I can comment on us, and that's kind of what we've done today. So we encourage you to test it out yourself and see.
Okay, thanks.
Hello. So talking about the custom vision, let's say that I have a model that has been trained to detect any object. It has happened sometimes that depending on the light, I want to verify a picture that I have taken, and depending on the light and the brightness and the exposure, it hasn't recognized. Is that a way that the custom vision can help me on previously enhance that image prior to detect the object?
Got it. So, actually in the background of the custom vision service, not exposed to you, we do a lot of kinds of data augmentation. So, one of the things we try to do is automatically augment your data so that it's robust to certain kinds of noise and changes that you might see. It's a bit of a balance, so we don't do every kind of possible augmentation that you might do. I would say that we are currently investigating, literally like last sprint, this sprint, a couple more kinds of augmentation that may help in more scenarios like that. But there's always kind of going to be a balance where sometimes we'll be able to kind of automatically generate data for you to improve your classifier, and sometimes it'll be necessary to provide more examples. And in fact, one of the things that's the hardest for me with custom vision service is when people ask me, well, how do I make my model better? In most cases, the answer is the same that it is in every case when you're kind of doing computer vision stuff, which is I gotta get more data. But I think we're doing everything we can to make it so that you have to provide as little data as possible. So having really strong pre-trained networks, having good data augmentation pipeline. Sometimes the answer just is you gotta get more data.
Will cognitive services be branching out beyond just the modalities that you have now into things like auditory and olfactory? Like smell, essentially?
I would say that Microsoft is huge. We have an amazing research team that's doing honestly crazy things every time we talk to them, and Cognitive Services works really close with them. What that's going to go to next, we don't know, but they do really cool stuff, so maybe.
Cool.
Awesome. Well, thank you everybody for coming. I really appreciate everybody, and particularly appreciate our demoers who are able to talk to some of the awesome work that they're doing at their own companies. That was I think very cool to be able to get to see from me personally. And I appreciate all of you that came today. And please feel free to reach out if you have kind of questions, comments, etc. And thank you so much.